Hi folks, in this video I'm gonna talk about forecast accuracy metrics. I guess most of you guys already know about forecast accuracy metric, but knowing is one thing and applying it correctly is another thing. I notice many people already know about it and they come to me and say, oh, my forecast accuracy is more than 85%, but still they face stockouts. Why that happens? When I dig into it, this happens because most of these guys have the good forecast accuracy number, but the way they are using the matrix is incorrect. So this leads to stockouts and wrong supply chain decisions. So in this video, I'm going to talk about those forecast accuracy metrics, issues, and provide the relevant solutions. So those metrics include bias, mean absolute deviation, mean percent error, mean absolute percent error, weighted mean absolute percent error. So now let's get started.
Let's start with bias. You see the formula in your screen that says bias equals to forecast minus actuals. And you also see the bias percentage, forecast divided by actuals minus 1 times 100, that gives the bias percentage. I put down this table for item A, B, and C for a given month. I have the forecast listed here and the sales actuals. And then I calculated the bias using the same formula that says D5 minus C5, that is forecast minus actuals for all three items. And I also calculated the bias percentage for all three items using the formula you see in your screen, D5 divided by C5 minus 1, that is forecast divided by actuals minus 1. And I also have the total bias including all three items together. So here you see that minus 25, this means the forecast is lesser than actuals, that is negative bias. The forecast is more than actuals, as a positive bias. Similarly, you can calculate the bias for other months as well. See in this screen, I calculated the bias for month 1 through month 6. I have the actuals listed here. I have the forecast. Then I have calculated the bias in this table here using the same formula. So this is how bias is calculated. So what's the problem with the bias? Let's talk about it. The problem with bias is it's not a pure forecast accuracy metric. It just tells how the forecast is deviating from actuals. Either it is going in the right direction or in the left direction. Now let's talk about another metric that's called MAD, that is mean absolute deviation. You see in your screen the formula, actuals minus forecast. The formula is same as we saw in the bias, but only difference is we take the absolute value here. And I also put down the table that gives the MAD for all the three items. I kept the same forecast and the actuals. And I also calculated the MAD for all three items together in line 11. Right, let me make it a little bigger so you can see that. See here. So similarly, you can calculate the uh, mean absolute deviation for more than 1 month. See in this table. So I calculated for more than 1 month, that is month 1 through month 6. I have the actual listed here. I have the forecast, and then I calculated the MAD using the same formula. So what's the problem with MAD? Let's talk about it. In my opinion, the problem is when you try to compare the forecast accuracy or forecast error for more than one item, then sometimes it's misleading. For example, let's take a look item A and item C here. Item A, you have a mean absolute deviation of 25, and item C, you have mean absolute deviation of 30. It's not too far off, it's very close. But when you see the actual versus forecast, it's a big difference. In item A, you have 40 pieces forecast versus actual. The difference probably is more than 50% between 40 and 65, right? And if you see item C, we have the forecast 220 versus 250. The difference is not too far off, right? Probably 10% deviation from forecast versus actual. So here the deviation is minimal, right? So in terms of the percentage error, right, item A is much higher than item C, right? But the MAD is saying that is very close. So it's very difficult to get a big picture when you try to compare multiple items together, right? So this means that we need to have another matrix that can give us percentage error So we can compare one item to another item. So we have MPE, that is mean percentage error. In your screen, see the formula here, that is actual minus forecast divided by actuals. And I have the table here. I have the actuals and the similar forecast for atom A, B, and C. I calculate the MPE for all three items, and I also calculate the forecast accuracy. It's nothing but 1 minus MPE. Right, so I use the same formula, C7 minus D7 divided by C7, that is actuals minus forecast divided by actual. And I calculated the MPE for more than 1 month, month 1 through month 6. I have the actuals here, I have the forecast here, and then I have calculated the MPE using the same formula. So now what's the issue with MPE? Let's talk about it. The problem with MPE is if you try to calculate the forecast accuracy or forecast error at the group level that contains more than one item, then if one item is showing over forecast and the other item is showing under forecast, then it can offset each other. I give you one example. In this case, let's see that item A, B, and C. Let's suppose all these three items fall into one group, right? So item A has 38.46, that is under forecast because forecast lower than actual. Item B over forecast 15%, and item C 12% under forecast, right? But if we calculate the MPE at the group level, all three items together, it will say MPE is not too bad, it's just 13%. But in reality, item A was too bad, that's 38%. And item C and item B, they was going one direction and the other one going another direction, right? So it's misleading, right? And if you have two items which have similar MPE in the same group, then your MPE would be zero. For example, if you have one item that has 20% MPE positive and the other item has negative MPE 20%, then if you calculate the MPE together at the group level, your MPE would be zero, meaning forecast error would be zero. So your boss will be very happy. Oh man, you're doing very good job. But in reality, it's not the case. Then we need to have another metric that can resolve this problem. So we have MAPE, the same formula, except the fact we calculate the absolute value here. I have the same table, forecast, actual for all three items. I calculate the MAPE map using this formula. You see C7 minus D7 divided by C7. So I calculate the absolute value of the error, C7 minus D7, and divide by C7, that is actual. And I put the forecast accuracy, that is 1 minus map. And I also have at the total overall level. So similarly, you can calculate the map for more than 1 month. I have the actual listed here. I have the forecast, and then I calculated the MAPE for all three items for multiple months using the same formula. So what's the problem with map? Let's talk about it. The problem with map is it gives equal importance to all the items, but in reality it should not be the case. For example, let's take a look item C. We have actual sales 250 for a given month. And item A 65 pieces, right? So any drop or any improvement in forecast accuracy in item C will have much larger impact than item A. So any improvement in forecast accuracy or error in item C will improve the customer service level much faster than if we put our effort on item A, right? Because 250 versus 65, right? So 1% increase in forecast accuracy will have a much larger impact versus 1% improvement in forecast accuracy on item A, right? So we need to have some weightage on item A, B, and C. So that's why we have another metric that's called weighted map or weighted mean absolute percent error. And you have the formula listed here in your screen. The same formula for MAPE. The only difference is we have attached a weight onto this formula. The way we calculate the weight is actual of that item divided by total actuals of all the items together. So for example, for item A, this should be 65 that is the actual for item A, divided by 360. That should give the weight of item A. That's what I put here. C7 divided by C10, that is C7 is actuals of item A divided by total actual. Similarly, we calculated the weights for item B and item C. So item C has much higher weightage than item B and item A. So it makes more sense to me. Now you see the weighted map for item C is 8% and item A is 6.9%, right? So this tells that item C should have more importance when we do the forecast accuracy or forecast error evaluation versus item A, right? And this makes perfect sense. So what's the problem with weighted map? The problem is with weighted map and also with map is it does not tell if we are doing under forecast or over forecast. This means that we need to have another metric using with weighted map or map. What I do, I use bias together with weighted map and map. The bias can tell me either I am doing over forecasting or under forecasting, and the weighted map or map can tell me what is my forecast accuracy or forecast error. So that's how I do forecast accuracy metrics. So that's all about forecast accuracy metrics or forecast error. If you have any question, you can put your questions in the comment section and I will respond to you as soon as possible. Thank you so much.